Hey guys, so we're going to take a look now at kinetic energy, and the thing that this is really centered around is just the definition in and of itself. So the definition of kinetic energy is energy of motion. And in chemistry, what we're really looking at is motion of particles or molecules. And so any time that a particle moves faster, that really is directly correlated to a higher temperature. And so in chemistry, when we're referring to kinetic energy, or kinetic energy changes, we're really looking at temperature changes. And temperature is measured in degrees Celsius for this concept. And so to calculate kinetic energy, we use this formula. Q is equal to mc delta T. And delta T really is the key to this concept in that if we're calculating kinetic energy, we have to have a component of temperature within that formula. So anytime you see this formula here, you know that you are making a kinetic energy calculation. Now energy always is measured in units of joules because that's the units of heat or energy, but we have to use this temperature number here in order to indicate, hey, this is a kinetic energy change. So the way that this formula is broken down here is Q just represents heat, mass or M represents mass, and this is usually measured in grams. C stands for specific heat capacity, and this is a constant for whatever substance it is that you're using, and this is found in your data booklets. You can find a variety of different specific heat capacities in your data booklet, but that's measured in units of joules per gram degrees Celsius. And then this last one, delta T, is just representative of a change in temperature. We can break this down into temperature final minus temperature initial. That's how you would calculate the change in temperature of the solution that you may be measuring, and this is measured in degrees Celsius. That's the units of it. So if we break this formula down and we do some unit analysis here, we take a look at this and we go, okay, if I've got grams times by joules per gram degrees Celsius, we can see that the grams cancel out. And then the degrees Celsius also cancel out because I've got degrees Celsius on the top and also on the bottom, leaving me with just units of joules here. Now, you can see sometimes where questions may give you a unit of mass in units of kilograms. That's fine. All that means then is that then your heat number will end up being kilojoules instead of just joules. And so again, unit analysis is really important here as you kind of look through what it is that you've got in the question and what your answer is going to punch out as in terms of its units. And so heat here in this example usually punches out as joules. Okay, so we're going to jump into specific heat capacity in a little bit more detail about it and what it is. Remember the units are joules per gram degree Celsius, and the definition really is found in the units. So I've got the definition written here on the board, but essentially what this just means is the joules on the top means how much energy is needed or how many joules is needed to raise 1 gram of a substance 1 degree Celsius. So we've got some examples of some specific heat capacities here that are just pulled out of your data booklet on page 3. And this is aluminum and this is iron specific heat capacity. Now aluminum specific heat capacity is 0.897 joules per gram degree Celsius. So again, what this means in terms of quantitatively, it means that I've got if I have 0.897 joules of energy, that will raise 1 gram of aluminum 1 degree Celsius. And if I had 2 grams of aluminum, then obviously I'd need twice as much energy in order to raise it still the 1 gram, or the 1 degree Celsius. For iron, you can see that it has a specific heat capacity of 0.449 joules per gram degree Celsius. So this one takes almost half as much energy to raise 1 gram of iron 1 degree Celsius. And so in this example right here, if we kind of apply that knowledge to it, if I've got 200 grams of aluminum and 200 grams of iron, and I add to both of these blocks of metal 1,000 joules of energy, the question then becomes which block is going to be more hot. And so you can pause the video right here if you want, generate an answer, and then hit play, and we'll go through the answer. Okay, so let's take a look at the answer for this. So a mistake that many kids make when they make this determination is they think, okay, well, aluminum has the higher specific heat capacity, which means it will have a higher temperature. And it turns out that it works in the inverse. It works opposite to that. Remember that specific heat capacity is how much energy is required to raise 1 gram 1 degree Celsius. So if this specific heat capacity has a higher number, in this case compared to iron, aluminum has 0.897 joules of energy per gram degree Celsius. That means that this is going to take way more energy in order to raise the block of metal 1 degree. Whereas this one, it doesn't need as much energy in order to make it go up 1 degree Celsius on the temperature scale. And so if we add the same amount of energy to both of these blocks and they both have the same mass, that's the key thing here too, is that they both have the same mass, then the iron is going to end up being way more hot because only smaller portions of this total here is going to be needed in order to raise it up on the temperature scale. Whereas for aluminum, it's going to require larger chunks of that 1,000 joules that's available in order to raise it 1 degree Celsius. And so the answer actually for this is going to be the aluminum block. So that's a little bit of what you need to know about specific heat capacity. Let's go through some examples. Okay, so here's some quick examples on how to use this formula and the types of questions you might see. Really, it's just a matter of what does the question give me, plug it into the formula, figure out what the question's asking me to calculate, or maybe do a little bit of algebra to rearrange the formula and then just plug it into your calculator. But here's question number 1, where we've got a mass of water, 125 grams, and it absorbs some heat, and this is key. And the temperature change due to the absorbing the heat increases by 14 degrees Celsius. So this temperature change as a positive number is important because our number should punch out as a positive heat because we know that water absorbed heat in this question. And so when I plug this in, I get 125 grams times by my specific heat capacity of water and times by the temperature change of water, and I get my number here, 7,333 joules, or in other words, if I were to express that in kilojoules, 7.33 kilojoules. This is a positive number because the temperature change is positive. That's important when we take a look at the second question, because if you take a look at the second one here, we now have the mass of aluminum, but it's losing heat. It's becoming colder. And so if it loses this much energy, its temperature decrease here is going to be negative 15.2 degrees Celsius. Now remember, this is a temperature change, not where is it on the temperature scale. So this is not that the aluminum is at negative 15.2 degrees Celsius. It's that it's lost 15.2 degrees Celsius. So it may have been at 97 degrees Celsius, and a loss of 15.2 degrees Celsius would bring us down to a new temperature that would be lower than that. So that's what this negative 15.2 degrees Celsius means. It's a temperature change, indicating that we've lost energy. And so if we've lost energy, again, this indicates that we should have some kind of negative number here for the amount of joules or the heat that's involved. So negative 3,240 joules divided by, again, the specific heat capacity of aluminum. That's found in your data booklet, 0.897 joules per gram degree Celsius. And then the temperature change, which is a negative 15 degrees Celsius. Now you can see here, we've got a negative divided by a negative, which should give me a positive value when I'm looking at my mass. And it in fact does. And my mass punches out as 238 grams. So you can try this, test this in your calculator, make sure that I've done the math correctly. The last one here is just one that you can do on your own. Try and get a sense for how to do this and do some work on some paper. So you've got the problem written here. One hint that I want to give you is just make sure that you pay attention to the units. Remembering that the units need to cancel out. If you take a look at these two examples here, the units cancel out nicely, and I get the units that I'm looking for over in my answer. For this one, you got to pay attention to what units things are written in. and make sure that you're either changing the units appropriately in the question so that units can cancel out and give you what you're looking for, which is units of degrees Celsius. So I've written the answer over here. 39 degrees Celsius is the answer. Good luck as you take a run at it. And that's it for this video, guys. Thanks for watching.